Can you solve this, or this, or even this? Because most people can't. And today, I'm going to show you how sum, difference, and double angle formulas can turn scary-looking trig into something that you can actually understand. Hey guys, welcome to my channel. Today we're diving into something that might look scary at first, but don't worry, it's actually kind of cool. We're talking about trigonometric identities. You know, all those formulas with sine and cosine that somehow help us simplify or solve trig expressions. But before we jump into how they work, let's rewind a bit. Trigonometry actually goes all the way back to ancient Greece. Yes, way before calculators, TikTok, or even algebra, people were figuring out angles using the stars. One of the earliest known mathematicians to work with trigonometry was Hipparchus. He's often called the father of trigonometry because he created one of the first known trig tables. Basically a super ancient version of your calculator's sine and cosine buttons. Later on, another Greek mathematician, Ptolemy, expanded on his work and used trig to study astronomy. So yeah, trig has been helping humans figure out complicated stuff for over 2,000 years. Over time, these formulas were refined, and now we use them in pre-calc to solve problems and also to stress out students. Okay, so first we're going to be talking about sum and difference identities. To solve these kind of questions, you're going to need a set of formulas. Yes, 4 of them. Looks scary. No, don't worry. When things get confusing, we just turn to our magical formula sheet. Think of this as your math guide, or even your hero. You can always Google Trig Identities cheat sheet to have this. But to make your life easier, I've dropped the exact same one I'm using in the description. Alright, let's get into some examples. So this is one of the questions that can be solved using the sum and difference identities. So we look at it, it looks kind of scary, but we can find a pattern here. So let's put variables a and b instead of pi and pi over 5. Then we would have sine A cosine B minus cosine A sine B. Then we look at our formula sheet and we can find the formula in difference identities. Look at it. Sine A cosine B minus cosine A sine B is equal to sine A minus B. So we just put sine pi minus pi over 5. And now we would be able to solve the expression inside the parentheses, and we would have sine of 4 pi over 5. So the next question is that if sine A equals 2 over 3 and cosine B equals negative 3 over 5, and both the angles A and B are in quadrant 2, evaluate cosine of A minus B. So the first thing that we can do is to sketch out the angles. So the question says that both of them are in quadrant 2, so we sketch them like this. Sine of angle A is 2 over 3, which means the opposite side of angle A is equal to 2 and the hypotenuse is equal to 3. And about angle B, the cosine of it is negative 3 over 5, which means the adjacent side is equal to negative 3 and the hypotenuse is equal to 5. Okay, now we've got the angles, and let's see what are we going to evaluate. So we have to evaluate cosine of A minus B, and this is when we go and look through our formula sheet. And we would see that cosine of A minus B is equal to cosine A cosine B plus sine A sine B, which in this case is equal to negative root 5 over 3 times negative 3 over 5 plus 2 over 3 times 4 over 5. And we evaluate this expression, then in the end we would have 8 plus 3 root 5 over 15 as our answer. Alright, now it's time for double angle identities, or as I like to call them, double trouble time. We've got one identity for sine and 3 for cosine. But don't worry, they're all right there on your formula sheet. Alright, let's go through a couple of examples and see how these work. This is the first type of question that we're going to go through, and basically in these questions, we're just trying to make this look like the formula that is written on the formula sheet, which is sine of 2a. So we can write 14a as 2 times 7a. So basically, we've replaced the a in the formula with 7a. And now for the answer, the regular answer would be 2 sine a cosine a, but remember, we replaced the a with 7a, so we write 2 sine 7a cosine 7a. And the question is done. This next question is a little bit trickier, but still we can do it. So usually on the other side of the equation, we've got a 2 multiplied to sine a cosine a. But in this case we don't. So we can assume that 1/2 or 1/2 has been multiplied to this equation. And whatever we do to one side of the equation, we have to do it to the other side as well. So we multiply 1/2 to sine of 2a. And about 2a, so the a in this equation is 12a. So we would write sine of 2 times 12a, which would give us 24a, and the whole equation would be 1/2 sine 24a. Okay, now we have to prove this identity, which is 1 plus cosine 2x over sine of 2x equals cotangent of x. In the proving questions, we have to show that the right side of the equation is equal to the left side of the equation. We can start by writing the double angle identities in another way. So we've got 1 plus cosine of 2x. For cosine of 2x, we can write it as 2 times cosine squared of x minus 1 over sine of 2x, which can be written as 2 times sine x cosine x. So 1 minus 1 is equal to 0, so we would just have 2 cosine squared x over 2 sine x cosine x. And we can cross out the 2 in the numerator and the 2 in the denominator, and also the cosine of x in the numerator and the denominator. So we will have cosine x over sine x left. And also, let's move to the other side of the equation. We've got cotangent of x. We can write the cotangent of x as cosine of x over sine of x. And yes, we can now see that both sides of the equation are the same. So this is the last question that we're going to be solving today. And we have to solve this equation for when x is greater than or equal to 0 and it is less than 2 pi. And we have to keep it in exact values. So the question is cosine of 2x plus cosine of x is equal to 0. So we can write cosine of 2x as 2 cosine squared x minus 1, and we write plus cosine x. So when we look at this, we find out that we can factor this, and we can say that cosine of x is equal to a, or any other variable that you want, and we can rewrite it as 2a squared plus a minus 1 is equal to 0. And we can factor it, and it would look like 2a minus 1 times a plus 1 is equal to 0. And now we would replace the a's with the cosine of x, and it would look like 2 cosine x minus 1 times cosine x plus 1 is equal to 0. As we know, when two expressions or two numbers are being multiplied, if either one of them is equal to 0, the equation would be equal to 0. So we would separately set each of these expressions equal to 0 to find out the solution to this equation. So first we would say 2 cosine x minus 1 is equal to 0. Then we would find out that 2 cosine x is equal to 1, and cosine x is equal to 1 over 2. We can think with ourselves that when we have the x equal to 1 over 2, and we can figure out the answer using the special triangles. And the answer would be pi over 3 and 5 pi over 3. Now let's not forget about the other expression. We would say cosine of x plus 1 is equal to 0, then cosine of x would be equal to negative 1. And we would soon find out that x would be equal to pi. And then the whole question would be done. Okay, so now let's see what we've achieved till now. Sum and difference identities, mastered. Double angle identities, crushed. Congratulations, you're officially a trig master. And hey, whenever you feel stuck, remember, it's just patterns, just formulas. Look at your formula sheet, you've got this. Thank you so much for watching this video. I really hope it helped. And hey, math can be tough sometimes, but you're tougher. Just take a deep breath, check your formula sheet, and keep going. You've got this. Seriously. See you next time. Bye!